Hello and welcome. I'm Bill Wake. This is our first episode looking at Dijkstra's shunting yard algorithm. It converts infix to postfix. So given an infix expression, 3 plus 4 times 5 minus 2, a normal arithmetic expression, we convert it to postfix, 3, 4, 5 times plus 2 minus. And the reason we do that is because it's easy to evaluate. We can evaluate by putting it on another stack, and we can get the value 21. I've posted a link to Dijkstra's 1961 paper that describes this technique. What he envisions is like a railroad shunting yard. So on the right-hand side, you have input. It's going to be a queue or sequence. It comes in and it can either go straight to the output or it can go down to the stack, and then later at some point the stack can go back out to the output. And it's a very clever visualization. There's some rules. So numbers just pass through. So 3 plus 4 times 5, the 3 is just going to slide on through. The operators, we decide whether the precedence is higher on the stack or not. And so we might pop some operators, and then we push an operator. And then at the end of all the input, we might have a few operators on the stack. We're going to pop those off, and we'll be done. I've been exploring a particular visualization approach, and what I do is a slight modification to the algorithm. We'll run it in the global thread instead of the main thread, because the main thread is what's used for the user interface, the view of the thing. We also add some sleep in so that we slow down the algorithm enough to visualize it. We modify the data structures the algorithm uses, so we make them be observable object with published fields. That way they'll notify the view when things change. And then we also make sure that any changes to the data structure run in the main thread. Finally, a new data structure probably has a new view component, so we have to create another component that manages that. I'm looking at a way we might get there, and what I think we'll do is we'll create the queue first and then a visualization for it. And then with that in place, we'll hook up the algorithm visualization so that we can see the algorithm as we develop it. Then we'll implement the algorithm starting with left associativity and precedence, and add parentheses. I don't know if we'll bother with right associativity, but at some point I want to harvest the visualization code, which means package it up and learn how to do that with Swift. I've copied those steps into the to-do for this program, to-do file. And we'll take a walk through some of these other classes. The app sets up the initial content view, and then the content view has what we're actually displaying for our application. It defaults to Hello World, and there's a built-in preview that we can use to edit it while we go if it's UI components only. I've pre-built some icons just to make things look a little more realistic. I find it helps. And then we'll have a sample test, just one test case, and we'll fill that in with the work we want to do. All right, so to make our queue, we'll just start with the stack, and we'll duplicate the stack tests and change it into queue tests. And we'll just start with the first one. So instead of a stack empty, we're going to start with a queue that's empty. I'll just take the name stack out of all these methods. Okay, we'll change this to Q. And we'll modify the stack and turn that into a Q. They're very similar. You just, which end do you push, which end do you pop? With that, I'll take you back to the original sessions audio. Well, anyway, running the tests, I said this should be a true. I'm making it return a false. I think that test should fail. I don't know what happened there. Let's try that again. Okay, that's better. Let me just comment out these. They'll run because they're still written in terms of stack, but just to kind of make sure we're okay. All right, so I think we'll just kind of quickly take the existing implementation and see if it works. Q, empty, stack, empty, same deal. Should be fine. Good. All right, next one. Q, well, in this case, we want a stack to become a queue. I need a better generic name for these things. I call them what they are, but okay. Queue. And I don't know, add seems like a better name for a queue. Some people will do remove front, add rear, that kind of thing. But we'll just take care of it here. So this is add. It's a void function now. I'll just assume it will fail its test without that. All right, so here you can see the thread thing. So part of the algorithm visualization says any changing, mutating method has to do its work in the main thread. I'm not enforcing that in the test. I don't know if I should or not. The testing of it's kind of weird. Like, does it run? Yes, it runs. You know, what if you run it in another thread? Does it run? Okay, so in this case, the add we're adding on to the end, so that seems fine. Yeah, I guess the first will be a little weirder. All right, so this should pass. right. This one. Remove can retrieve items. Okay, let's change this to a queue. Change the name. There's another way to do this. Okay, so I'm saying there's a front and there's a remove and a front and remove. So we're splitting the push and pop equivalents. All right, but we have to add two methods. And let's make this value one. I don't mind the 1-2 stuff here because they are just sort of paired kind of things. Okay, so add a 4, add a 2, get value 1, get value 2. Well, value 1 should be 4. This is the difference between a stack and a queue. And value 2 should be 2. And at the end, that queue should be empty. Okay, so we need the front and the remove. Front is our analog to top. Front, and we'll leave it at the bad version, the stack. And remove is our equivalent to pop. Okay, and we'll leave them equivalent to what was there before because there's stack variations, and we know that's wrong. So it's a little artificial, but just trying to kind of quickly get through these. I'll just run the one test. We expect it to fail with 2 and 4. It should be as empty as true, though, I think. Okay, 2 is not to 4, 4 is not to 2. All right, so let's grab the, well, adding adds to the rear, that's fine. This should become first, and then we need to remove first. Okay, and I think, well, description we can get for free. It's more of a debugging thing for us, so I'll just take that now too. All right, and this should now pass. Oops. Yeah. Easily said. Okay, running tests. All right, and then finally, knows its contents. Again, we got to change stack to queue. Oops. And the contents we want to come out in the other order, in stack order or queue order. So we push 4, push 2, we should get 4, 2. And we need to member contents. Yep. Okay, and again, we're taking the old version because we know it's bad, just to see the test fail. This is not quite straight up TDD, is it? But it's getting us there. Oh, I guess I got to say add. Now there are libraries for this stuff that use consistent terms. So I remember Bertrand Meyer with Eiffel try to make a very, make them all very clear about add and using the same term over and over consistently. Um, it's this trade-off. Are we explaining things more in the terms of the particular data structure, or are we making it more similar to the other things? Because once you introduce a DAC, which is a double-ended queue, then you do have to distinguish adding to the front and the rear and all that. So I don't know. It's a trade-off always. All right. So rather than reversing the queue, because for a stack, we're just going to use the queue as is, and that should be fine. All right, we'll commit this. So what we've done so far is we've created queue with tests. All right, and so I'm not coming at this from the normal TDD mode, right? Usually I might start and then drive through to create the queue and the stack and so on. But I'm starting from the point of view of I'm trying to implement this particular algorithm. And it would be easier if I had these data structures in place, and they're well-known data structures. So why not just put them in place? So we're doing it that way. All right. Let's see our to-do. So implement the queue we've done. All right. And I guess I should be... make the Chiron update. All right, implement the queue view next. Okay, so let's look at the stack view. That's our analog. Okay, so that's well, at one point we had the stacks vertical and horizontal and trying all these different things. What we want to do, well, I'm definitely not doing TDD on these. I'm just, I just kind of want them to work, but to develop this thing, I pretty much want, I want to make the real, we want to make our view do it. Hey, it finally previewed. Okay. I'll say resume. Hopefully it doesn't take too long to get there, and do a quick demo here. Oh, paused. What's your problem? This is the sort of thing I worry about. It just seems to jam up sometimes. Doesn't help too much. All right. It built. Okay, so the green light's on. So if I change it, that's fine. I can do that live. If I want to add something to it, I think I can do something like that. I think that colors is it background? Hopefully without, yeah. Okay. Obviously should stick to what I know. Okay, what did we have? But at any rate, we can modify it. Yeah. So this is the Swift UI stuff. So the old way is called UI Kit, and it's much more drag and drop. This one is more kind of specify an interface and let the layout system take all your specs into account, and try and lay it out properly. And the reason they do that, my interpretation anyway, because you've got so many mobile phones of different sizes, and you've got the iPads, and you can run this on Mac, and you just don't know what the size constraints are. They're thinking like, if we let the system worry about it, we can do better. And so things like spinners and all that stuff, they can look completely different depending how much space they have and where it decides to put them and all that stuff. Okay, so front end web mostly React. Yeah, this will be a bit different. Not 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 terrible. um, although, you know, uh, I'm definitely in the dabbler stage on this stuff, as you've probably realized. Okay, so we've got this. The way this works is we create these views, and we put objects of some sort in here. Well, um, I can put a queue view. I guess I want to imagine that that's in place. Let's go ahead and again. I think I'll duplicate the stack view. Is probably a good starting point. And what I'm thinking for a queue is really, I think it should just display the items in order left to right. And I think I've got these divider bars that just sort of outline it top and bottom. Um, well, they're trailing leading. We'll have to modify that. But um, I think that'll give us an okay view. You know, just like I had the ladders in the other diagram or the railroad tracks. You know, we'll just stick a sequence of stuff there and see how it goes. All right, so I'm going to make it a queue view. All right. And again, I'm just going to modify it. Start similar and then work our way up from there. So I'm making this thing hold items that are hashable, and custom string convertible means they have a description. Excuse me. Let's see. So we got this observed object. So notify when that changes. For each queue item's contents, display the item's description. It's pretty, you know, it's kind of there. It's doing it vertically for the stack, but let's see what it looks like, and then we'll work our way from there. So I think we can just create. Well, we'll just create a temporary version that's the queue is of type queue of int for now. Let's just do that. Okay. And then in here, we're going to say queue view and we have to pass in the queue. Queue. Did I change the name? Yeah, queue. It's going to hold a queue. And observed object, content view. This should be state object. Okay, so that says create the queue. Cannot find queue. Okay, so we'll just create one. All right. Oh, come on. Expected expression. Well, that looks like an expression to me. I mean, I should be able to just say this. It should infer it. Expected expression. Oh, var. Okay. Let me bring up my last one and just... If it weren't for the previous projects, right? Okay. Towers of Hanoi. All right, here's our content view. Observed object var tower of type. Oh. I guess. Well, observed object is because I'm creating it elsewhere, doing things differently. So you can create the view coming in the app, and that's what I'm doing up there, is passing in the tower. But observed object, state object should be the version of that says I'm creating it for you. Property wrappers are not supported in top level code. Well, let's pass it in like we did before. And then that'll require us to do it at the application too. Go back to the type and not create an actual one. Okay, and then the app is going to have to pass in a queue. Okay, so we're saying create one, pass it into the content view. Oh, it hasn't built this. Same deal here. Content view. Oh, I've got all this in the wrong place. Okay. How about you? QUEUE. And let's make another one. Okay. We're working our way towards an empty queue is all we're going to be able to see. But with this, we should be able to resume now. We made too dramatic of a change. Let me close that. Okay. So we should get something. Maybe some empty bars. Yeah. Okay. That's actually progress. Okay. Let's put a couple things in. I can do it here. Let's see if I can make this work. At state object var q equals q of int. Excuse me. Where's the moment I can push? That's tricky. You don't just get to do regular code in these views. It is similar to React in that sense. It's kind of inspired by it. The behavior is supposed to happen elsewhere, and then this just reflects the current model here. Well, I'm going to modify my queue for just a second. No, that's not going to be easy, is it? Okay. What would make this better? Well, let's make some Okay, now I'm trying to make something owned by this thing, and it's going to be the input. Well, let's try this. 3, 4, 5. Okay. And let's and conform to observable object. Okay. Let's just do state. Okay. And then can I do dot button? Let's do a vertical stack. Button. The title is add behavior is, I don't know if I need my input even. Let's just do q.add3. Okay, I'm just trying to get some components in here so I can do stuff. Try again. Okay, so I'm saying create a vertical stack of a queue and a button. And then when you click the button, I want to add 3. And let me, again, I'm going to reference my previous app. Cannot preview syntax error. Okay, so the button, yeah. Well, I probably have to do that. But that seems okay. Where's the error? Stack view. Stack content view. Stack button view. Am I counting right? That should match this one. Next. 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 Okay. Expected. Okay, I think it just caught up. We'll run tests, and then I'll get this preview going again. All right, we got far enough to see. It's got the queue there now. Okay, and I'll hit resume. Again, I think this is the empty queue so far. Okay, and I think if I do anything, it's not going to trigger the action, so we have to actually run it to see it. Okay, and we're starting up over here. I expect an empty queue and an add button, and then if I click add, I should get 3 and then 3, 3, 3 added in. It doesn't deal with duplicates, or it just repeats them. So it's running. It's just slow. Okay. I know I'm due for a new computer. I keep saying that. All right, so while this is starting up, we're due for a break. So let's take a break. We'll come back. I assume it will have started running for the first time then, and just 2 or 3 minutes. All right, see you in a couple. All right, welcome back. Okay, yeah, so we are running at last. Didn't hang around to see if it took the whole 2 minutes, but I should be able to hit add, get a 3. Yes, add, get a 3, and another 3. All right, the line there, that's something, I believe that's even a bug in the Swift UI stuff, but it's okay. Notice we're stacking it up, and you can't really tell if it's coming into the top or the bottom because I'm always adding the same number. But that's okay. I mean, I'm seeing something happening. That's progress. Okay, so let's look at the queue view itself. Okay, so What I would like is I want this thing to be a horizontal thing. So let's change this to an H stack. Okay, so this should be going across the page instead of up and down. So I should get something that looks more reasonable. And then alignment, I think there's supposed to be a left. Oops. Bottom, top. Well, maybe leading was okay. No, I want bottom and top. Okay, so let's put a top and a bottom. Okay. And then, I don't know, can I get some... How about, is there like a random... I think this gives me... Oh no, that's going to be a seed. Let's try it without. Is that going to work? No. Wants a float maybe? Oh. It is deciding. Argument of type void. Okay. Maybe I do have to call a random number generator. No. I don't think it's hard, but I don't know how to do it. Swift. Random in. Okay, wouldn't have guessed it. Let's try throwing some dice. Static function on int. Okay. Can I convert void? He's still back on that. All right, let's keep running tests instead of the real thing. I mean, the test should pass, but it sort of clears out some caches when you switch between testing and simulating. All right. Try this again. My hope is that first one was just the bad one. It should be a little quicker. But I have noticed the simulator is not that fast on this stuff. I hope it's... I can't believe there's anything that would slow it down enough on a real situation. Okay, that's a little better. Top and bottom lines. Let's see if it stays between them. 4, 1. Yeah, now we're talking. Okay, I'm rolling really well, aren't I? Okay, now that's all kind of big for what I have in mind. I don't know if I... Let's see, is it... You can simulate a hardware rotate left. Okay, because we want 2 Qs. I mean, we can keep our expressions moderately close. We'll just see what happens. It may have to do some shrinking or something. Hopefully that's more automatic. All right, the spacing here is a little much. I don't know if that's okay. Let's just try taking this 20 out. All right, run that again. This will be padding around the text items. I think that might be enough padding. Okay, I can definitely work with that. Okay. So we have a basic Q view. All right, now let me go back to my Keynote. Basically, the picture I want is I want to have the output queue on the left, a stack in the middle, and the input queue on the right. I don't need to worry about this little interchange thing. I'll just let that be there. Okay. And I guess those three things should be passed into you. They should come into our view system. We can create them elsewhere. I guess we need something somewhere to, well, we want to type the input. Maybe we'll put something up here. It'd be nice if it was all the same object, but I don't necessarily need that. So I'll put some sort of dialog box up here that you can type in, and the go button will add that to the input queue, call the algorithm, and the algorithm will use the stack and produce the output queue. I think maybe the algorithm will own those things and we just get them. Okay, let's see what we're up against here. All right, I'm gonna hide this and let's go back to this thing and just view our content view there. Not doing that right? Okay, whatever. All right, so what we've done is we've said there's an observed tower object, okay, and that will correspond to our algorithm. I don't know what we should call this thing. It's a converter. It's a prefix, infix to postfix. I could call it a prefix postfix converter. Yeah. And then the second, another thing I think we could do once we get this working, I'm inclined to put another stack out here and run the postfix into that stack and do the evaluation and maybe produce the final output over here. Yeah. But let's get this part going first. All right. So we've got the observed object. We're going to make up this algorithm. So let's put, I want to put a shell on it. So I think what you should do, well, when you want to convert, right, you're going to create one of these things. You'll have it lying around. You'll say convert, and you'll give it an input string. It'll push that into its input queue on the right and then do its job. Okay. And for starters, we'll just get the shape of it in and then we'll make it work. Okay. We'll get the shape in so we can view it, build a content view for it, and then we'll implement it for real. Okay. So I'm going to create a new file. I just love the little visualization of this as moving cars around on a railroad track, you know, to swap engines or whatever. But we'll keep it more generic. Okay, so this is prefix converter tests. I'm using John Reed has a package for the XC test suites that automatically finds this, imports, creates this, and throws in a dummy test. All right. I don't know what we're going to say happens, but let's define something. Okay, so we have this prefix converter. So let converter is prefix converter. Okay, and if you say converter dot convert, well, what should happen? Let's just say 1. If you've done that, then the converter dot output should equal, and I don't know if I've got this working right, but let's do that. Okay, so if you create this converter, you feed in a string, it's going to convert. Oh no, it's got to be a string coming out too, because it's going to be a string of characters. I mean, it's going to be a string of numbers and digits or operators. So we'll keep it in the character domain. I don't know. We'll see what we got here. But we're just going to do the bare minimum. Now, is there a way to convert? I don't think there's any freebie that will generate this for me. All right, so let's add this new file. Now it's the Swift file. Prefix converter, it's in Shunyard, that's good. Okay. And we said there was an initializer, which takes a string. Input of string. And there's a convert method, which just, oh no, input was nothing, convert takes the string. And I'm gonna try it this way. Okay, I'm overthinking, I'm sure. All right, so that does that, and then we had something we promised would be there, right? The output, which is a Q in our vocabulary. So var Q output Q of character. Well, I don't need the type if I actually make it. Okay, I think that will be a dummy that will at least fail its test. Cannot convert Q of character to type string. Okay, let's do output dot contents. That's what we put it there for. And this should fail because we're not doing anything. And my proposal is I'm just going to shove a 1 in that output and call it a day for now, just to see if we can get the shape there. All right. Add a string 1. Okay. So this is kind of fake it till you make it. This is pretty minimal faking. All right. And the test should pass. But notice what I'm getting. I'm trying to get the methods that I need in place, which is the constructor and the convert and the existence of the output field. All that stuff is there now, so I can draw it even if it's the wrong value to look at, but that's okay. All right, so with this case, we're not trying to get the VStack per se of the Q. We're going to have to change this around a little. So what we want to hold is the converter. Okay, so let's we'll just mutilate this converter of type prefix converter. Okay. Observed object. Prefix must conform to observable object. Is that what we did before? Does our tower? Yes, it must. Okay, we will do the same. So we're putting in the constraints are coming from the UI as well as from the code we wrote. Okay, content view. So we're holding an observed object. That's fine. We're going to put a Q view, which is converter dot output. Okay, and then we're going to put a stack view, which is what? Well, it's going to have to be converter dot stack. Okay, so it needs a stack. Of characters. And then it's also going to need an input, not to take away from what's going on here. Cut out a step or two. Okay, so we've got an output, a stack, and an input, and those are the three things we want to display. How we get them, it's going to be a little funny. I'm going to get them on the screen, and then I'll start working them around. Okay, I will. We'll just get rid of that for the moment. Okay, so now our thing has to take a converter. So let's take. Well, we'll take the fix. I don't know that there's a keystroke for that fix. It would be nice. Okay. And now we need to pass a converter in for our preview. Is a prefix converter. And same thing in our top level. Okay. And let's run. Isn't that weird? It's a little, I'd call it a simulator bug. All right, not so pretty yet. Ad's doing nothing. Okay, but it's the pieces are there, so let's work on it. Okay, so I think what we really expect to have, in effect, I want to have I want a vertical stack and a horizontal stack. So I want these more horizontal. and these more vertical. Okay, I'll put a spacer at the bottom and the top just to kind of get some decent look out of it. Okay, so we got the spacer, the 3 views, another spacer, another button, and let's do well, let's call converter. So converter.convert with, and then I'm just going to hard code the string 3. All right. Let's try the preview, see if I can get enough. Oops. Okay. We'll resume. Okay, that's my empty stack. If I hit convert, I should get a 1 somewhere. Oh, no, this is the view. Okay, I kind of wish my empty queues would show something too, but I don't guess they get to. We could do something in the view to force that. All right. Well, that seems okay-ish. Let's run the real thing. So right now our 3 convert 3 is ignored, and we're just shoving a 1 in the output stack or output queue. We're not making any use of the stack or the input queue yet. But I'm just trying to get some pieces on the screen and start fiddling around until I get something that plausibly is a view of what we're looking at. Okay, let's see if this does anything. Hey, something. Okay, we're still getting a line, vertical line in our... so annoying. Again, as always, if you know what's going on, please speak up and we'll try and fix it. But, okay, so I don't know. We've got... Let's reduce this. 12. That should push it down a little. And maybe our converter. Oh, there we go. I'm just going to add something just so we get something in there. Okay. Again, I don't really care what it does at this point. I'm not trying to make it work. I'm just trying to get some pieces in there so our visualization can look plausible. I will at some point. I'll want to move the stack a bit lower in the picture so it looks like the queues are above, but we'll let it go. All right, well, these big red lines are from the stack, I believe. All right, so what can I do? Let's see what we can do on this view. So I think HStack, I'm gonna I want to have 3 pieces. All right. The stack. Well, let's see. Let's find the Q picture. Q view. I don't know, these overlays, top and bottom, just haven't been good to me. I tried to do it on the stack originally, and they just weren't happening. Again, I feel like it's hard to tell from the documentation, but I feel like I've got a bug in there somewhere. So let's take those out. And I want to see if we have enough visualization that I can plausibly get the algorithm moving forward. And I think we do. It ain't pretty, but it's enough to get started. The step I want to do, actually one more piece, I think we should have an input string somewhere that we can type go on our button. And that string should be the input to convert. Okay. And another add's not going to do anything. Oh, we will. Okay. Yeah, hconvert is doing that. Okay. Let's see. So convert content view. Okay, so I'm going to call this go. And I'm going to say there's a text field. Oh, and I just forget. I know I have to do a binding to it somehow, but text field example Swift UI will be a lot faster than me guessing 8 random ways to do it. All right, so we'll do the state, text field name, text colon that. Okay. Okay, text field. $1 says make a binding out of it, so it'll use our state, I hope. Okay. I'll just put that there. Preview still trying. Okay. We want to center that. I guess he is centered. Let's give him some padding. I'd really like the padding on the right. I will have to look that up. It doesn't make a big difference for where we are now. Okay, but I do want to get my input to be user input dot. Oh, I guess it's just user input. Okay, because this is a string. All right. And let's see. Close out some of this stuff. Okay. Yeah. I don't think anything will happen with our text. Am I? There we go. 1 plus 3. Oh, I probably should have. We've hard coded it. The 1 plus 3. Okay. We just said throw pieces in every component. All right. That's good enough for now. We'll get fancier. I'm definitely approaching this in a spiral. Hopefully it's just not wrapping around, but you never know. All right, let's get the algorithm going. So let's go back to the algorithm. All right, numbers pass through. So our simplest test is really just one number, and you give that for your input. What we should see is it shows up on the input. It doesn't go into the stack, and it just shows up on the output and deletes from the input. All right, and that'll get us started. Okay, so we'll handle expressions of the form this. We're only going to do one character digits because I don't want to worry about tokenizing or any of that stuff. But that's okay. We can see enough to be interesting. All right, so let's go to prefix converter tests. I always forget this. Is it up arrow? I took a note somewhere. Command control up arrow. All right, there we are. And I'll lock it in. So, well, actually, this initial test is if use a converter convert 1, then the output content should be 1. Let's we hard coded it for our tests, right? We just said push 1 into the output. Let's do the work now. So you've got the input string. We're going to say input string dot for each, and what you're going to do is input dot add $0. Okay, $0 is the implicit argument to the iteration. Okay, so we're going to push them into the input queue, and then we're going to we'll do it manually for the moment. Input dot let's do output dot add input dot front, and then input dot remove. Okay, so if you feed in an input string, we're going to load that up into the input queue. We're going to move the first thing from the input to the output, and then remove the first thing. And I hope our tests still pass. Okay. Let's run. Now I think we're going to see, the first thing we'll see is, well, we'll see it properly parse the expression 3 or 7 or something like that. I guess we'll use 7. We haven't used that number yet. And that'll be fine. But if we did 2 digits, well, we don't have anything clearing. We should probably fix that. But if we did 7, 8, we would see it push both numbers in the output, and that's not legitimate. It's 7 space 8. We'll skip the spaces, but you know, 2 tokens, just numbers, can't follow each other in the grammar of infix expressions. So it's not enforcing any syntax rules. It's just saying if I see an input, it's a digit, I'm going to push it to the output. Okay, so 7 should be fine. If I do 7, 8, which should be treated as 2 numbers, well, I think we're going to get 7, 7, 8. It pushed 7. I guess we'll get the same. Yeah, we need to do some clearing and stuff between these. All right, let's add a clear. Okay, we'll just create a converter. Okay, if we convert one and then we say converter.clear, we expect the output contents to be empty. And we expect the input contents to be empty and the stack to be empty. Okay. No method clear. Whoops. Wrong side. Okay. Test should fail. And maybe we'll make it more complicated too. I think that might be wise. Okay, in this case the output is there. Let's go ahead and push a bunch of stuff through. We don't really know that it's working properly. I mean, we know it's not working really properly, but if you say clear, it should restore itself to the original empty state. That much we know. I always have my tests on the left for some reason. I don't know about always, but it feels feels like I'm trying to grab the wrong one. Okay, so now these two have stuff in them. Yeah. All right, so let's clear. And that's really this without the var. Okay. Should pass. All right, and now we want to call clear in here because we're just keeping it around. So let's do converter.clear and run. All right, well, while that's getting ready, we're due for another break. We'll take 2 or 3 minutes again, and I'll see you. We'll come back and hopefully get this thing moving forward on the algorithm side. I always forget to look at the clock, but I'm sure it's been a couple minutes. All right. This is running, so I can put in, let's put in 7. I expect 7 in the output. Oh, I know something we haven't done. All right. If we put in 7, 8, yeah, I think if we put in 7, 8, it should transfer the 7 to the output and we don't transfer this second digit yet. I mean, we don't have a loop or anything. We're just moving one thing from input to output. Um, Now, what I think is going on here is we didn't do the main run the main algorithm asynchronously. It didn't matter when we were just testing that thing, but we really do need to do this if we're gonna see a visual. Okay. Um, I guess there's no harm in doing it across the whole thing. Okay. Yeah, and in the real world, I mean, 7, 8. If you have to imagine we're already eliminated spaces and stuff like this. If it were real tokens in a programming language, if you just said A B, two separate identifiers, it doesn't multiply them or anything by default in most languages. Even if you can write it that way in math. And same with 7, 8. It's two integers in a row. It's not legal syntax. But this algorithm is not going to detect that because it's just not the way it works. It relies on somebody's already made valid syntax first. All right, so again, we'll try 7, 8, and I hope the Go triggers it this time. 7, 8. I can't tell if it did or not. It blinked. Converter clear, converter.convert. Okay, let's see our code again. It should add the input string. Well, I'm going to go back to my my version here. I'm going to say use sleep, and then microseconds. So a million is a second. So we'll do 500,000, I guess. But let's pause here. Half a second, so we can see the input and the output, I hope. Okay, now do we need to do anything? I guess the inputs, the add on the queue already enforces that notification on the main thread. So I'm hoping this does it. But nothing coming through is disappointing and weird to me, and I don't see what would have created this problem. Okay, let's try 7, 8 again. And maybe I should just start with 7, but we'll try 7, 8. I'm expecting 7 to show up on the right-hand side, pause, maybe 7 and 8 on the right-hand side, pause, and then 7 show up on the left-hand side. That's not what I'm getting. Oh boy, and I've been terrible about committing. I don't know what we did differently. Okay, so initial works, clear works. This should be doing something. The content view calls convert. Calls on the global dispatch. All right, let's try just 9. So that should work. I mean, that's more than half a second. All right, let's print. I don't know. I feel like it's just easier to print when you've got these multiple threads running. Like I just don't trust stopping at the threads and stuff. Pass clear and then done. And here we need to view the console. My problem is I don't know if I have a display issue or a calculation issue. I guess this will at least reveal the go button is triggered, right? Okay. Pass, done, and clear. All right, so converter. Input for each. Oh, I probably want this sleep down one, don't I? So we add them all to the input, we take the front thing off, and we sleep. Okay. I don't mind if my algorithm doesn't work at this point, but I want my visualization to work. Okay, so let's look for 2. Go. Everybody seems to be doing their thing, but I'm not seeing anything on the screen. Ugh. Let's see, is everybody... Oh, you have to say published. I think that's what I haven't done. And have I done it in the queue? Published I did. Okay. Let's try again. Again, I'm going to compare the old one. My tower says published for the stacks. Okay, and the pegs, yeah. That's good. The published stuff is basically syntactic sugar. You can create publishers on your fields manually, but it's handy enough, I guess. All right, just for variety. Here we go. Oh, hey, we got our pause working too. All right. Yeah, just making sure things display is really tough when you do these things. Okay, so we cleared. And our queue, whoops, prefix converter. I'm gonna say a second is better for us. And same thing afterwards. Let's see, so this is output.add. We get stuff. Now maybe I want it before and after. Output.add. Yeah. Maybe we'll do this one a little shorter. Now, in the long run, we'll have a loop and we'll do things that way. But just for now to kind of tune what we're seeing. I want to get the sense that it's sliding across. I don't think I'll get that good a visualization, but we'll see what we can get. All right. 6 will go. Yeah. It looks a little fast. All right. But I think we're okay. So the input string, I think the stuff from 20 down is our algorithm we're going to make. Okay. So publishing threads from background change. Maybe I need to do this. I didn't complain about the others. And this stuff is kind of what's challenging me to learn when how do these things interact. But basically, if I have a published field and I change it, I have to make sure it changes on the main thread. This, I'm doing that because I'm not changing the object. I've got the same object, but I'm changing its input, and that's already dealt with on the other side. So I don't know. We'll see. All right, let's push 8 through and kind of watch the timing. I want it to show up on the right and then show up on the left and then delete from the right. It seemed like it did. I'd have to watch the replay. All right, now if I do it again with 9, it should clear and do it. Yeah, it definitely showed up more on the other. Okay, so I think where we are on the rules here, rule 1, numbers pass through. Okay, next operator versus stack. Well, if the stack is empty, the operator just goes on it. So let's deal with that. So we're gonna make ourselves able to parse 1 plus 3, or 2 plus 2, more classic. So we will need to decide, are you a number or not? I mean, basically, we're looping on the input. Okay, so while the input's not empty, we're going to do stuff. All right, so I think we can safely generalize that now a little bit. Well, here's previous converter. Let me move clear up. Okay, So I think the generalization I want, while not input dot is empty, I'm going to do stuff. Okay, so there's my loop, so I can sleep inside my loop. Okay, I'm going to take the thing off the output and then remove it and do them all. Okay. Yeah, so now I expect, like, back to your question, if 7 8, I think the output should be 7 8 bar bar, nothing on the input at this point. And I'm doing this generalization. I may be, well, let's see what happens. It's so weird to do an algorithm like this that doesn't guard against stuff, but we're relying on the input to have done that for us. I mean, if you had done, say, recursive descent parsing, you've worked your way down to the pieces, and as you find each piece, you could do this, I guess. I don't know that they did recursive descent in this one. I haven't read the whole article. But it wouldn't surprise me because the algol does. But all right, I'm going to put a big long string in, and the way we're doing it now, we don't check anything that's in there, but we expect to see the input string go to the output string. Hey, okay. 7939 XKSK 3 plus pound. That is not my password, but it did the right thing. All right, so I think we can visualize now. I'm happy about that. All right, I think our algorithm does the step that says if it's a number, it shoves it to the output side, but we don't check that. So let's do the next most complicated expression, which is like 1 plus 1. All right. And let's do that here. Okay. And I'm going to keep the 1 plus 2 because it's easier to distinguish. You know, if I do 1 plus 1, I can't tell if the first one is coming out of the second one first or whatever. So, I do that, then I should be able to say converter.output.contents should be 1 2 plus. All right, I'm very sure we won't get that. Conflicting arguments. Oh, I have to be. I'm still sure it won't get the proper output because right now it just shoves everything one at a time from left to right. Not a comma, a bracket. Right, come on, fail. Okay, good. And we think it's going to be 1 plus 2, and we know that we don't want that. Yes. Okay. So let's say if, well, I guess we're going to say if input dot front is number, we'll live with that. We know we got characters. Okay, if the input is a number, we're going to do something else. We're going to do something else. Okay, if the input's a number, we're going to add it to the output and remove it from the input. add. I don't think we need this sleep. And I think I'm going to move this one up. Okay. So this was happening with numbers. Input.remove. Let's move that down. Okay. So I'm working my way up to this. I'm now shoving numbers to the output side, but I'm not doing anything with the plus. I'm eating it. So I expect to get 1, 2 as my answer, which I think is a better answer because at least it's right 2 out of 3. But it's not a complete thing. This else has to be filled in. Okay, and the converter test, I mean, we're expecting 1, 2 instead of 1, 2 plus. Yeah. All right. So the thing that's supposed to happen is some complicated thing with the stack, and let's see if we can make that simpler. So we're supposed to look at the precedence and blah, blah, blah. We're not going to worry about that one. We're just doing a simple example. I'm just going to push the operator on the stack, and at the end, I'm going to pop the ones off the stack. Okay, and I don't know, is that too obnoxious? We got to pop the ones off the stack no matter what. Okay, and we got to push. So we're doing the back half. Push the operator and pop the remaining ones. Okay, because this test case is just driving only so much. Okay, so what we wanted to do is we want to say, well, we want to say stack.push input.front. And then remove it from the output. And then at the end, we're going to pop. Well, we're going to have to capture it. Let op equal stack.top. And we're going to move it to the output side. Op, and we're going to remove it from the other side. Stack.remove. Okay. So push one operator. When we see the operator, we push it, and then we pop them at the end, and it's just 1 right now. Okay. I think this will pass our 1+2 test. It's not quite good enough. Come on. Oh, I have this in the wrong place. It should happen after the while loop. Because these are all the things that happen with the inputs. So, yeah. I'm predicting failure. Let's see what test initial is. Why is that? Crash with signal ill. What? I don't. What does that mean? When there's a photo to unwrap optionals and a continuous integration bundle. What's going on? All right, well, let's move this out. Perhaps that's causing the issue. So this is consuming the input. And we're moving it somewhere. All right, let's rebuild. Try again. I don't know if oh, well, if there are no operators on the stack, it's going to blow up. So we have to watch that. Already our other tests are protecting us. Not quite the way I expected them to, but there's that. I kind of hate sitting around. Let me just see if I've... let's see, it's on the scheme. I think I turned off the debugger during testing. Test, yeah, debug executable is not there. All right. Okay. I do think I'm going to have an error because this must be my stack crash popping, and when there's no operator, if you only have a 1, right? This has to be in a loop. Okay, so let's see. While not stack is empty, we're going to do some stuff. While the stack's not empty, pull off the top, pop it, and write the operator out. Okay. And I haven't been keeping up my to-do either, have I? All right, implement a queue view. We did that. Hook up the algorithm visualization. I would say we've done that. It's probably not quite where we want it. All right, so we're on, basically we're on this one. All right, we got our green lights. Okay. Well, we're basically running out of time. Let's refactor this a little. I can output.add. I can do that here, and then I can inline this. All right, and I'm going to do the same thing in the stacking, or the while loop. I'm going to put some sleeps in there. Okay. Now this one, I think we can let symbol equal input dot front, and then we can reference symbol is number, and this is symbol, and this is symbol. Okay. And then no one's going to care if that's in the old thing or not at this point. I think it makes sense to conceptually remove it before adding it to the rest so it's not duplicated. All right, let's run the tests, run the output, and call it a day. Okay, so next time is tomorrow morning, 9 to 11:30 a.m. Eastern Time. If that's not convenient, this will be on my YouTube channel in about 2 weeks. I think got a little bit of a lag. But I'm hoping this passes the test still, and then we'll do a quick run and see where we are. We'll show one thing that can work. I think 1 plus 2 times, let's see, 1 times 3, 1 times 2 plus 3. Let's try that. So I think in this case, the 1 times 2, the time should, let's do 1 plus 2 times 3. Yeah, let's do that. And I think it'll get the right answer, but it doesn't, it's only because it coincidentally follows the right precedence. All right. Okay, why I would be writing Illinois DMV motorcycle practice test just completely seems out of nowhere. All right, so 1 plus 2 times 3. 1 plus 2 times 3. 1, 2, 3 times plus. Yes, okay. All right, we'll leave off there, and thanks for joining me today. Hope you can catch up with me next time or in the future, and take care. Bye-bye.